Oh, and good morning. So here we're back working on Swiboe, the next generation text editor, and we were in the thick of things working on key mappings for the GUI. So what do we have so far? We have something that is called, where am I? Oh, that's like completely the wrong directory. So let's try that again. Filling the text editor here. There we go. So we have a Lua test file. There we go. Where we actually like I dreamed how I would like the key mappings to work, and right now we basically only have a bunch of functions up here, and down here that's our first key map. So basically the map takes a key combination that is a arpeggio of chords. So in this case it is just if you press I, then a function that I called when, which will decide if this key map is currently valid or not. So you can like implement something like normal mode or visual mode or something like that through that. The priority, which is also not used right now, so let's ignore it for now. And this is actually the function that will get executed. And right now it doesn't do much useful stuff except for just printing something out. And if I actually run this now, then we will see that it actually like executes the script. So it prints this hello that is up here, and it also executes this map, but this map is not really doing anything in code right now, so we have to change that, and that's what we're working on. So we are working on the config file.rust thingy, and here we actually, this is our Lua map function, and we already did some serious work here. We have already implemented a Lua table, which gives us access to the data in that one, and now we actually want to pass the keys from that. So let's pull up here on the right side how this Lua table is looking. Where did I put that? I guess it's in the same file, isn't it? Oh yeah, there it is. Like here are the tests. So here on the right, here we have the Lua table, and it actually implements all of the useful stuff. And what we need is get array values as keys, right? So our keys is then table get array values, and that will be strings, reference to strings, and the entry is called keys, right? And that returns a result type that is either an error or a vector of into type. So like this has to be there. So we're just going ahead and unwrapping here and adding a no-com. This should not crash if the key is not there. But we're outlining right now, so that's fine. And this one is still complaining about something, right? This has to look like that. And now let's output those keys to see if it's actually working. And it says it takes 0. Right, because like this is already the table. We actually, if we look at our Lua file, we actually we're working on this table right now, right? Which is the outer table, and we actually want the table that is the keys table, and we want the entries that is inside of that. So going back to the former file, we actually want the keys table here, and that has to be mutable, and that will be called get table keys unwrap, and then I guess this has to be like that, right? And that actually doesn't take a key at all because those are the integer keys which are defined already. It's still not happy. Cannot borrow table is mutable more than once at a time. It says so because down here we actually get a function from the table. Okay, so it's unhappy, like the borrow checker is unhappy that we're accessing the table multiple times. So let's scope that, and then it should actually work, right? So basically the borrow checker is unhappy because here we borrow something from the table that like borrows the table mutably, and then we access it, and then we still kept the mutable borrow around, and that is something that Rust doesn't allow. So when we try to do the same thing down here again, it complains that we try to borrow something that is already borrowed again, and that's not legal. So we actually only take the borrow for a short amount of time. That's why we introduced this scope here, and now it's happy. And you can see down here, right, the keys actually passed correctly. We only have an I, but we actually don't want the keys. We actually want a arpeggio. So we actually want, from the keymap handler, we want a arpeggio, and that is new. So how does the keymap handler work? Oh, I already wrote a from vec struct. How convenient. So from vec, and that takes a vector of strings, and we unwrap here too and add the same no-com, should not crash, right? And now we have a beautiful arpeggio. Perfect. And actually we want to hold on to this arpeggio. We just call it the mapping. So we return that from this block. What's up now? Ah, there we go. So we return it from this block, and then down here we pull out the function. We do that here. So that will be like very much the same. We get the table and the function, and now we pull out the config file runner, which we like, that is basically our Lua state, so we might rename it eventually, not sure yet. And that actually contains the keymap handler, and we use the keymap handler to actually now append. Here we go. So in the keymap handler, we tell it that this mapping that we now have, which consists of this arpeggio, or this mapping, I called it, and that will actually just call through to this Lua function. And now we actually would like to test that. And how do we do that? Where do we construct this config file runner? Here we construct it, and here we run it. And actually, where is the binary file for that? Here we called it Lua testing, and that runs this function just config file runner run. Perfect. And now we actually fake a somebody typing. So in the keymap handler, we actually can fake somebody typing. Keymap handler insert key down. That's what we want. So in this one, we actually now fake a key down event, and that happens immediately, so there's no time delay, and that is called key. I guess like keymap handler, key, character, and I, right? And then we tell it that actually a timeout occurred, so it should execute what it has queued up. And now, if everything goes according to plan, our Lua function should be executed. So this is wrong. This is called config file runner. And still unhappy about what? In line 42. Right. So the arpeggio from vec actually would like to have a reference to str, and we actually pass it. What do we pass it? We pass it a vector that is a vector of strings, right? That's what it is like. Yeah, so this here is this here. is a vector of strings, and it would like to have a reference to a vector of references to strings. What does it do with this vector actually? It iterates over that, and then it constructs from string from that, and this is already taking a reference. No, but it should be fine if we say, like, basically we take a reference here, and then we say we here take actually a type t, and maybe that works. Who knows? Expected string front. Can I do something like so? That unfortunately also doesn't work. It expected. Oh, that's the problem. I don't need this magic, I don't think. I can just tell it here, like I actually like pass the key by value, but I have to pass a reference to it. And still not happy. But maybe like the combination of the magics, like so. Maybe like so. It doesn't like that. Well, I don't know. How can I actually tell it that this can be a references of store? I guess I can convert it here, but that feels weird. Should that do that conversion for me automatically? Not sure, but that definitely works. So let's construct a reference to keys table, which is like we iterate over the keys, and we map that. That already gives us a reference. Like this will be a reference to the store already, and I guess that's exactly what we want. So we can just say, well, collect this, and reference to keys is a vector of store, right? And now we don't pass this, but we pass the reference to keys, and still not happy. Wow. So why doesn't it like it? Oh, it says that this is a collection to strings, and we're expecting this a string. So basically, we really need the map, and we basically have here a reference to string in there, and we return this as a reference to string, and then we collect it. There we go, that was easy. Now come. This feels really weird. Is this conversion really needed? Not something that we want to try out and learn today. Wow, and now I really feel how the performance of my system suffers. Come on, computer, you can do it. You can do it. Oh, let me have a look here at my activity monitor real quick. There we go. Oh, look at that. Look at that. Look at that. What do we see? Is that actually what we expect to see? Guys, something weird is going on with my computer. It just doesn't want to work anymore. So what do we see, right? We faked one key press to I, and what do we see? It says the current mode is normal here, and then it says the current mode is actually insert, which is here, and then it seems like it's actually like calling the same function once again. So for some reason we actually type our key twice. I'm not sure how that came to be. Maybe I'm actually faking that key map somewhere else again. So let's have a look. So we have key down here, and where else do we call key down? So we call key down, yeah, that's the function definition. Those are all the tests. And we only call it here once. So maybe the function is then actually bugged and we don't actually want the timeout here. Who knows? I mean, the keymap handler is also like a very rough outline. It doesn't support everything we need eventually, and it's not correctly dealing with timeouts. Actually, it doesn't have a real concept of timeouts yet. So we actually have to revisit that eventually and make it less janky, I guess. Compiling, running, and now indeed we only call it once. So I would call that success. So basically what did we do? We wired up a configuration file parser that can actually pass keymaps and call Lua functions when these keymaps are actually somehow entered. And the next iteration, we actually have to look into like wiring this up to the GUI, and then we can define our movement commands in Lua instead of how we do it right now, which is in Rust. And I think that's good as it is. So let's like write that like actually pass. Yeah, let me go ahead in an editor and do it in there. So, wow, my computer is really suffering right now. So actually pass keymaps in Lua and verify that they work. Great. Next would be wiring them up into the Rust GUI. So no, not the Rust GUI, the terminal GUI. And that's it. Cool. So I'll push that, and then I'll actually like suggest it for merging. So that will be on GitHub, and it will be my Swiboe instance. And there we go, here's the pull request. No! And basically that is called wiring up the Lua config file parser to the keymap handler. That's what we did. And we create a pull request. And there is the pull request already, and since nobody actually, besides me, is working on Swiboe right now, unfortunately nobody can do the code review for us. So we tell Homu to go ahead and merge that immediately. And that's done. Next step, as I said, will be to actually using the setup that we just constructed